Okay, continuing with number 5 of composite functions. So let's write down what our functions are. We have f of x equals 6 square root of x, and then we have g of x equals 6x. And our first one is f of g of 4. So a So first we're going to put 4 into the g function. So g of 4 equals 6 times 4. 6 times 4 is 24. I'm going to substitute the 24 into this, the f function. So f of 24 equals 6 square root of 24. This is where I tell you to go ahead and be sure you downloaded that calculator. I don't know where mine's at, so I may just do mine in my head, but I wanted to show you. So on this, if we had this, we could do 6 second square root of 24, and it would go ahead and simplify it for us. So this would be very useful if you have this, or if you don't have this calculator, you can go ahead and I sent out on the concerns thing a link to download the Texas Instrument one for free. If you lost that and you're watching this and you want that, email me and I can probably copy and paste it and send it to you. So this equals 12 square root of 6, and that is going to be our answer. So B is G of F 2. So first we're going to substitute 2 into our f of x function. So we have f of 2 equals 6 square root of 2. There's not a square root of 2, and 2 doesn't simplify, so that one's good. Then we're going to go to g, and we're going to have 6 square root of 2 equals 6 times 6 square root of 2. All we do on this one is 6 times 6, so we have of 2 equals 36 square root of 2. I'll show you on this. So, going on to C. C is f of 1, so f of 1 equals 6 times the square root of 1. The square root of 1 is 1, so we'd have 6. Then we'd have f of 6 equals 6 square root of 6. That doesn't simplify, but if you're stuck on these, you can always check. So our answer for this composite function is 6 square root of 6. D, we have g of 0, so we're going to substitute into the g function, which is g of x equals 6x. So g of 0 equals 6 times 0, which is 0. Then we need to substitute again to get the composite of it, so this one is 0. Copy this down. So you have 12, 6, 36 square root of 2, 6 square root of 6, and 0. Okay, number 6. So our functions on this one, we have our f function is the absolute value of x. G function is 32 divided by x squared plus 8. And I guess these are all the same. It's the composite of f and, okay, here we go. So we have f of g of 4. So first we're going to substitute 4 into our g function. So g of 4 equals 32 divided by 4 squared and 8. So 32 divided by 16 plus 8. We're going to simplify that fraction. Eight goes into both of them. So you have 4/3. Then we're going to substitute 4/3 into our f function, and since it's the absolute value, it's just going to be, but I'll still write it out. So f of 4/3 equals the absolute value of 4/3, which is 4/3. So f of g of 4 equals 4/3. These might take up more space than the last one. B, g of f of 2. So we're going to substitute 2 into our f function first. So we have f of 2 equals the absolute value of 2, which is 2. We're going to substitute that 2 into the g function. So g of 2 equals 32 divided by the sum of 2 squared and 8. So we have 32 over 4 plus 8. So 32 divided by 12. That won't divide perfectly, so we're going to simplify that fraction. Thirds, and that would be our answer. So 2 equals 8/3. And since our f function is just the absolute value of x, we'd have the absolute value of 1 twice. But so f of 1 equals the absolute value of 1, which is 1. And then we do that over again. Or we could have had f of x equals the absolute value of x. So either way you want to look at this one, if we put 1 in there, it's still going to be 1. So and then we have g of 0. So first we'd substitute 0 into the g function. So 32 divided by 0 squared plus 8. So 32 divided by 8 would be 4. Then we're going to substitute the 4 into this equation, which is going to take us back to the very first equation we did. So be sure you take good notes. 32 over 4 squared plus 8, which would be 32 over 16 plus 8, which is 32 over 24, which reduces to 4/3. G of 0. Okay, maybe we're done doing 4/3 here, 8/3 here, 1 and if f of x equals the square root of the sum of x plus 4 and g of x equals 2 divided by x, then which of the following does f of g of x equal? So on these, before we were solving for each of them, now then we're going to take our g function and substitute it into the f function for x. So we have the square root of, and then we're going to have, instead of x, we're going to put our g function there. So we substituted this in for x. So for f of x equals 5x plus 9, g of x equals 9x, find the following composite functions and state the domain of each. So f of g of x, so we're going to substitute the g function into the f function, and we got to simplify these, so we'd have 5, and then instead of x, we're going to have 9x plus 9. They're not going to take this as an answer. Go ahead and multiply that 9x by 5. So we'd have 45x plus 9. Then they ask about the domain on this. There's nothing that's going to make this one undefined or unreal, so the domain is all real numbers. Then we have g of f of x, so we're going to take the f function and substitute it in for the x on the g function. So we'd have 9 times 5x plus 9. And then multiply that out, so 45x, and then 9 times 9 would give us 81. So 45x plus 81. There's still nothing that's going to make this one unreal. There's not a square root. There's not an x on the bottom of the denominator, so all real numbers. Here we have f of x, so we're going to take our f function and substitute it into the x of the f function. And then we'll distribute our 5. So 5 times 5x is 25x. 5 times 9 is 45. And we still have our plus 9 on the end. So 45 plus 9 would be 54. So we'd have 25x plus 54. Domain still the same on this. G of x. So we're going to take our g function and substitute it into the g function for x. So 9 times 9x would be 81x. Same thing, except now we have our f of x function is x squared, our g of x function is x squared plus 9. So we're going to substitute our g function into our f function, so we'd have x squared plus 9 squared. And you're going to have to FOIL that. So we have x to the 4th plus 18x squared plus 81. And I'll make a little note right here. So x squared plus 9 squared plus 9. And you'll FOIL that to get there. Okay. So x to the 4th plus 18x squared plus 81, all real numbers. Now then we're going to substitute the f function into our g function, so x squared squared plus 9. So this one would be x to the 4th plus 9. That one wasn't bad. All real numbers. F of x, so we'd have x squared squared. We have g of x, so we'd have x squared plus 9 squared plus 9. So if you were taking good notes, you can go up here and just take this again. But you're going to FOIL this and then add 9 onto it. So we'd have x to the 4th power plus 18x squared, add 81, add 9. So combine our like terms, plus 90. Our domain is all real numbers. What is f of g of x when the f function is 2x subtract 3, g of x is 1/2 times the sum of x plus 3. So we're starting with the f function and then we're substituting our g function into this. So 1/2 x plus 3 and then finish this. So there's a couple ways we could go about this. Since we have 2 times 1/2 times the sum of x and 3, this 2 times 1/2 right here, 2 times 1/2 is 1. So we'd have 1 times x plus 3 subtract 3, which would end up being x plus 3 subtract 3, which is just x. Then when we do the opposite, so this one was f of g. Now we're going to do g of f. So we'd start with our g function. So we'd have 1/2 times 2x subtract 3 plus 3. So on this one, I'd go ahead and combine my like terms in the parentheses. So I'd have 1/2 times 2x, because negative 3 plus 3 would be 0. 1/2 times 2 would be 1. And then they asked down here, does f of g of x equal g of f of x? And it is yes, because they both equal x. This next one, they use no natural numbers. They use a and b instead, but treat them like natural numbers. So we have f of g of x. So we're going to start with our f function, a, and then instead of x, we're going to substitute this equation. So 1 of a, x subtract b plus b. And if you notice on this one, it's number 11 is just like 10, except there's no numbers. They used a and b instead of 2 and 3. So on this one, a times 1 over a, it'd be a divided by a, and anything divided by itself is 1. So we'd have 1 times x subtract b plus b. So x subtract b plus b, negative b plus b would be 0. So that equals x. Then we're going to do g of f. So we'd start with our g function. 1 divided by a times, instead of x, we'd have a times x plus b subtract b. Combine my like terms on the inside. B subtract b would be 0. So 1 divided by a times x. This would end up being a divided by a again, and anything divided by itself is 1. So this would equal x as well. Are the composites equal? Yes. Find functions f and g so that f of g equals h. So they have h of x equals the square root of x squared plus 7. So on this one, I think the easiest thing to do would be to go through here and write them all out. So they're saying f of g. So we're going to take our g function and put it into our f function. So a is the square root of x, so we'd have the square root, and then instead of x, we're going to put in x squared plus 7. Well, that's the answer. But let's keep going. So here we'd have the square root of x squared, and the subtract 7 would be on the outside, because they just have the square root of x here. This is x squared equals, so we'd have the square root of x subtract 7, and all of that would be squared. Here we'd have the square root of x squared plus 7. So 8 is our answer on that one.